Today's experiment is on electrochemistry. We are going to omit parts A and B because those involve electrolytic cells, which brings in a whole lot more theory. And this is your introduction to electrochemistry. So we are just looking at voltaic cells. Voltaic cells are the ones with spontaneous reactions that create an electrical current, basically. So we're starting with, as far as your data goes, we're starting on page 10 with part C. And the first cell that we're doing is the Danielle cell. This is kind of a classic combination. Both of the solutions are 1 molar solutions because the voltage will depend on the concentration of those solutions, and you'll see that in the last part of this experiment. Anyway, I really kind of regret that you all can't do this because it's really kind of like magic. You just have these pieces of metal, just ordinary pieces of metal, and you hook them up with a wire. We do run it through a voltmeter. They are dipped into solutions that pretty much look like water. Copper ions actually have a blue color, but and then a current runs. It just seems like nothing's happening, but something is. This is a lot like those, have you ever seen a potato clock or a lemon clock where you have 2 pieces of metal, you just stick it in this fruit or vegetable and then it runs a clock? This is exactly how those work. The 2 metals are exchanging electrons. Anyway, so this is the standard one, and when you hook this up, the voltmeter reads 1.10 volts. Looks like the lead voltaic cell is already running here. It does have lead ions down here, and you can see the voltage that we got for it. And so all I've done is swapped out this one, this half cell, putting in the lead with the lead ion. Next, we're going to do aluminum. So this is a piece of aluminum, and in the solution we have aluminum ions floating around. And when we do this, I get 0.88 volts. Now you all, I'm giving you these voltage, but they do have some experimental error worked into them because I don't want you to just look up what these could be, but I want to see what you get. And actually that's more how things are in reality, that they're not going to be exact. Okay. Next we're doing nickel. So this is a piece of metal that is nickel, and we have nickel ions floating in solution. And when I hook this up, the voltmeter reads 0.53 volts. Last one, we're doing iron. Our iron, we would say a zinc iron copper, or a zinc iron voltaic cell. And so this is a piece of metal, iron, and this has iron ions floating around in it. They are iron 2 ions. And then the voltmeter reads 0.71 volts. Now I'm not going to promise you that some of these numbers aren't way off. I don't think they're way off, but let's just see. I got this data from somewhere, so let's look at our next part of our experiment. In part D, we are making 3 different cells. The first one is our standard Danielle cell with our zinc and our copper, and the voltage on this is 1.10. As before, these solutions are both 1 molar, 1 mole per liter of solution. And so as you figured out or from the notes, you know that if we change those concentrations, it's going to affect the reaction. And the key to this is realizing that this is an equilibrium reaction, and it shows you in the notes where voltage is as a reactant or product, and you're going to use what you know about Le Chatelier's principle and what happens when you reduce the amount of a reactant, equilibrium shifts toward it, and if you increase the amount of reactant, equilibrium shifts away from it. So be sure to see the notes on that. The first cell that I'm doing is that I have 1 molar of the zinc, but I have some diluted copper sulfate. And when we do that, it reads 1.02 volts. Okay, and then I put it back together, and this time I'm switching out the zinc solution to make it more dilute. And I'm back to 1 molar here. So when I do that, it reads 1.18 volts. So in one case, the voltage went down, and in the other case, it went up. And you will need to be able to explain that. So that's all the data that you need. Have fun.